Okay, good afternoon, Professor. We are doing the module 6, lab 6, post-lab video reflection, and this will have me completely caught up and current. So, just thank you and bear with me, and we'll start with the summary, experimental design and safety. Safety is still, all safety precautions are the same. So where I did my safety precautions, where my lab was performed, said over there around the corner through that doorway is the bathroom where the shower and sink is. Trash is right there. I had a fire extinguisher, gloves, heating pad, so my hands wouldn't get too cold, paper towels, all the essentials that were needed for the safety. Excuse me. First experiment for this module, we had to make ice cream, which was actually kind of weird. I've never done it in a bag. Same principle as using an ice cream maker, though, with the ice and the rock salt and the milk with the sugar and the vanilla extract. I didn't have that. Well, that was what the first one was about. Experiment number 2: effective temperature on enzyme activity. This was a little weird. Wasn't sure if I was going to be able to do this right or not, but I did get the balloons to blow up. So let's start with the results here. For the first experiment, so we got to flip pages. For the first experiment for the ice cream, had the temperature of the Ziploc ice in the Ziploc bag was 2 degrees Celsius. Temperature of the milk was 8 degrees Celsius. Temperature of the vanilla flavor sugar and the milk was 10 degrees Celsius. Temperature of ice with salt added was -1 degrees. Temperature of milk after shaking for a minute was 7. Temperature after shaking for 2 minutes was 7. Temperature after shaking for 3 minutes was 6. Temperature after 4 minutes was 5. Temperature after 5 minutes was 4. Temperature after shaking for 6 minutes was 3 degrees Celsius. And temperature after shaking for 7 minutes was 3 degrees Celsius. And that's when the change happened from liquid to becoming a solid. So we stopped right there. So that's the results of experiment 1, which ice cream could have been a little harder, but it was ice cream, and no, I did not taste it. Experiment 2, now with the balloons and the hydrogen peroxide, cold, hot, and room temperature. The balloon circumference I measured 11 centimeters, so that goes for all 3. Let's see, number 1 cold, the temperature was 11 degrees Celsius. The balloon at 11 degrees Celsius inflated from the reaction was 16 centimeters. Number 2 hot was 48 degrees Celsius. The balloon got up to 19 centimeters in diameter. Number 3 room temperature test tube, it was 20 degrees Celsius, and the balloon circumference was also 19 centimeters as well, just like the hot was. So I'm hoping I did everything right on that one. I also did do a bar graph, which I'll send to you to your email. I took a picture of it. For experiment 2, we kind of figured there'd be a gas So I figured that's what we were doing with the balloons. As far as a kinetics experiment, to me, I believe the ice cream was exothermic. I think I'm saying that right. Yeah, because it was a negative. Temp goes up during the reaction, or I'm sorry, that's for exercise 2. It was exothermic. For critical thinking, explain why the temperature of your ice cream ingredients did not change. The reason the temperature doesn't change when it during the phase is I want to say it's due to the molecules do not change, so the temperature does not change. So I hope that's a good answer for that. Why are enzymes common in biological organisms? That's a whole different thing. Good Lord, I'm stuck here. Enzymes are biological catalysts. They catalyze the chemical reactions that happen inside living things. So that's my answer for the enzymes. What else is it? Oh yes, the direction of the flow of energy. What I wrote down for my notes for this: energy flows from the milk to the ice. This removes enough energy to bring about a phase change from liquid to solid. And to me, that's how the energy should flow: is going from the milk to the ice. Or I should say the ice and the salt, but yeah, definitely that brings down, salt lowers the freezing point of the ice, which is endothermic. Then heat is transferred from the ice cream mixture to the ice, which actually makes the ice cream mix even colder. And eventually you end up with ice cream once the reaction happens after it's been shaken for a long enough period of time for that to happen. Self-reflection. Did everything go exactly as planned? I think I could have gone another minute or two longer with shaking the ice cream to get it a little bit more firm, but it was actually turning into ice cream, so I did achieve what the lab was supposed to do, I believe. Did this week's activity reveal any laboratory skills that still need improvement? I think timing with experiment 2, because there's a lot of timing. You had to do simultaneous things at the same time, trying to measure temperatures and this and that. So I'd say my timing of doing things simultaneously needs to be improved on, and I will work on that. I believe that's everything for this lab. Like I said, this gets me caught up on all my labs, and I will send you the photo of my bar graph. Thank you. Have a great day.